December 1941. The factories of Akron, Ohio. I'm at half speed. Inside vast brick buildings, conveyor belts move, but without urgency. Steel frames roll forward. Machinery waits. Something essential is missing. Not steel, not fuel, rubber. Outside, winter presses in. Trucks idle in loading yards, their tires already worn thin. On nearby airfields, training aircraft sit grounded, rubber cracked and brittle beneath the cold. In city streets across America, handwritten signs appear in shop windows. No new tires available. For decades, rubber had been invisible, taken for granted, harvested from distant plantations half a world away. It wrapped every wheel, sealed every hose, cushioned every landing. And now, almost overnight, it is gone. Maps on military desks tell the story. Southeast Asia, Malaya, the Dutch East Indies, Indochina, now shaded in enemy colors. 90% of America's natural rubber supply cut off in weeks. Not disrupted, erased. No speeches announce the crisis. No headlines fully explain it. But in laboratories, boardrooms, and government offices, the realization sets in quietly and heavily. A modern nation at war cannot move without rubber. And America is about to discover just how unprepared it truly is. Before the war, rubber was not a strategic concern. It was a commodity, cheap, plentiful, distant. For decades, the world's rubber flowed from a narrow band of earth straddling the equator. Vast plantations in British Malaya, the Dutch East Indies, and French Indochina produced nearly all of it. Trees tapped by hand, latex collected in metal cups, shipped across oceans in predictable rhythms. The United States did not grow rubber. It imported it, almost all of it. By 1940, America consumed more rubber than any nation on Earth. Tires for civilian cars, tires for trucks, tires for tanks, rubber for aircraft fuel lines, gaskets, insulation, boots, medical equipment, radar mounts. More than 400,000 tons a year, and rising. There were warnings. They came quietly, buried in trade reports and naval intelligence summaries. Analysts noted that Japan imported nearly all of its oil, iron, and rubber. They observed that Tokyo's expansion into China had not delivered the resources it needed, and they understood what that meant. If Japan went south, rubber would be a target. Yet in Washington and in industry, the assumption held. The oceans were wide. The British Empire was strong. The Dutch controlled the Indies. Rubber, like air and water, would simply continue to exist. Synthetic alternatives were known, but ignored. German chemists had developed artificial rubber as early as the 1930s. Polymers, derived from coal and alcohol, were already in limited production inside the Reich. But synthetic rubber was expensive. It wore down faster. It was harder to process. In peacetime, it could not compete with cheap natural latex shipped from Asia. American companies experimented only at the margins. Laboratories tested polymers. Chemists wrote papers. But there was no urgency, no mandate, no mass production. The market did not demand it, and industry rarely moves faster than necessity. By mid-1941, global tension tightened. The United States imposed oil and steel embargoes on Japan. Diplomatic relations frayed. Military planners began quietly stockpiling what they could. Rubber was added to the list, but too late. Warehouses filled with raw latex, but not nearly enough. Tire manufacturers warned the reserves would last only months in a full-scale war. The numbers were stark. Without new supply, civilian driving would collapse. Military mobility would follow. Still, no decisive action came. The belief persisted that conflict could be delayed, that access could be preserved, that plantations thousands of miles away would remain untouched. Then, in December 1941, the map changed in days. Japanese forces surged across the Pacific and Southeast Asia with speed and precision. Airfields fell. Ports were seized. Plantation regions were overrun almost intact. Rubber trees still standing. Latex still flowing, now under enemy control. The United States did not just lose territory it never owned. It lost motion itself. And only then did the full weight of the problem become impossible to ignore, because every road, runway, and supply line in modern war runs on rubber. That realization would force America into a race against chemistry, time, and its own assumptions, one that begins in the shock that follows the first blows of war. The shock arrived not as a report, but as silence. By early January 1942, ships that should have been unloading rubber at West Coast ports simply did not arrive. Insurance firms canceled routes overnight. Convoys were rerouted or sunk. The Pacific, once a commercial highway, became a battlefield. Inside Washington, emergency meetings multiplied. Charts were redrawn. Estimates revised downward again and again. The conclusion hardened with every briefing. America's rubber stockpile would not last a year. On January 7th, 1942, barely a month after Pearl Harbor, the federal government announced nationwide rubber rationing. Civilian tire sales were restricted. Speed limits were reduced to extend tire life. Gasoline rationing followed, not because fuel was scarce, but because tires were. The home front felt it immediately. Cars were parked. Buses ran longer routes on failing rubber. Farmers patched tractor tires with canvas and rope. Urban workers walked miles in winter darkness because streetcars could not replace worn components fast enough. Scrap drives began, not for metal, but for old tires, raincoats, hoses, anything containing rubber. Yet recycling could not solve the problem. Military demand eclipsed everything. A single bomber required hundreds of pounds of rubber. Tanks consumed tires and seals at a punishing rate. Training alone shredded rubber faster than factories could replace it. Without intervention, entire divisions would be immobilized before reaching the front. President Roosevelt called the situation a matter of life or death. And for once, the phrase was not rhetorical. The government turned to industry, not as contractors, but as partners in survival. Tire manufacturers were summoned. Chemical companies were pressured. Research budgets were unlocked overnight. At the center of this storm stood B.F. Goodrich. Based in Akron, Ohio, Goodrich was already one of the nation's largest tire producers. It had chemists, pilot plants, years of quiet experimentation with synthetic polymers that had never quite justified themselves economically. Now, those half-forgotten lab notebooks became blueprints for national policy. Goodrich engineers understood the challenge immediately. Synthetic rubber was not one material, but many. Different polymers behave differently under heat, stress, and friction. Some cracked in cold, others melted under load. None perfectly matched natural latex. And yet, perfection was no longer the goal. Function was. Working with federal agencies and other manufacturers, Goodrich began adapting German-style Buna rubbers into American production systems. Alcohol-based feedstocks were redesigned to use petroleum instead. Polymer chains were altered for durability over longevity. Tires would not last as long, but they would last long enough. At the same time, the federal government did something unprecedented. It built factories itself. Across the Midwest and South, massive synthetic rubber plants rose in months. Operated by private companies, owned by the state, fueled by emergency authority and wartime necessity. An entire chemical infrastructure was assembled almost from nothing. Mistakes were constant. Early tires failed catastrophically. Blowouts were common. Military testers reported delamination, overheating, sudden rupture. Each failure fed back into the system. Formulas adjusted, compounds revised, vulcanization times recalculated. This was not innovation in peacetime. It was improvisation under threat. By late 1942, the balance began to shift. Synthetic rubber output climbed. Not enough, but measurable. Enough to keep trucks rolling. Enough to train pilots. Enough to prevent paralysis. America had entered a new phase of the war. One fought not only with guns and ships, but with molecules and equations. And as production stabilized, a deeper question emerged. How this crisis looked from every angle, human, tactical, technological, and moral, inside a nation learning, painfully, that modern warfare depends on materials as much as men. That question opens the next chapter. For most Americans, the rubber crisis did not arrive as an explosion or an air raid. It arrived as absence. The absence of tires in store windows. The absence of buses on side streets. The absence of movement. In industrial cities, workers walked farther than ever before. Shifts started earlier to account for distance. In winter, cracked sidewalks and frozen streets punished worn shoes as much as worn tires. Newspapers printed diagrams showing how to patch inner tubes with glue and cloth. Housewives learned to save rubber bands like rationed food. For soldiers, the shortage was more direct. Training exercises were cut short to preserve vehicle tires. Tank crews drilled maintenance instead of maneuver. Aircraft ground crews reused gaskets while past safety margins. Every decision balanced readiness against depletion. And behind every compromise was uncertainty. No one could say when relief would come. Rubber workers carried a different weight. Chemists at Goodrich and other plants worked 12-hour shifts, 7 days a week. They tested compounds that failed again and again. Burned batches were dumped. Vats were cleaned and refilled. Each mistake felt personal because somewhere a convoy waited. This was not the dramatic heroism of the battlefield. It was endurance. Modern armies move on wheels. Infantry marches matter, but supply decides wars. Fuel must be hauled. Artillery repositioned. Airfields maintained. Every function depends on rubber isolating metal from shock, sealing pressure, absorbing stress. Without it, machines eat themselves. Commanders quickly grasped the implication. A tank without tires on its road wheels chewed through metal. Trucks with failing seals leaked oil until engines seized. Aircraft grounded for lack of rubber. Hoses became liabilities instead of assets. Tactical planning adapted. Routes were shortened. Speeds reduced. Maintenance intervals tightened. Vehicles were cannibalized to keep others running. It was a war of conservation inside a war of expansion. Inside American factories, the tempo shifted from efficiency to urgency. Production managers stopped asking what was profitable. They asked what was possible. Goodrich and its competitors rewrote assembly lines to accept new compounds. Workers trained on the fly. Quality control tolerated imperfections once unthinkable. Tires were stamped not for lifespan, but for mission suitability. Every successful batch was a small victory, and every failure sharpened the understanding that chemistry, once a supporting science, had become a frontline weapon. These angles converged toward deeper forces still at work. Technology straining to catch up with necessity. Leadership forced into unprecedented coordination, and a moral reckoning over sacrifice and survival. Those forces defined the next set of perspectives. Before 1941, polymer chemistry in America was a promising discipline with limited urgency. After Pearl Harbor, it became a national lifeline. Synthetic rubber was not a single invention waiting to be activated. It was a moving target. Each polymer behaved differently under stress, heat, and time. Styrene butadiene rubber, later known as SBR, showed promise, but it tore under load. Neoprene resisted oil, but cracked in cold. Blends offered strength, but complicated manufacturing. Chemists were forced to make choices with incomplete data. There was no decade to refine formulas. No market tolerance for delay. Every compound had to work now or be discarded. Laboratories became pressure chambers where theory collided with production reality. The federal government centralized this chaos through the Rubber Reserve Company, coordinating raw materials, patents, and plant construction. Competing firms shared data they would have guarded fiercely in peacetime. Failures were circulated as quickly as successes. Technology did not advance gracefully. It lurched forward under necessity. No single figure controlled the rubber response. That was both its weakness and its strength. Civilian agencies, military planners, chemical executives, and labor leaders were forced into constant negotiation. Decisions were made in weeks that would normally take years. Authority blurred. Responsibility overlapped. Mistakes were inevitable. But leadership in this context meant acceptance of risk. It meant approving factories that might never work, backing chemists whose theories weren't proven, betting national mobility on equations written days earlier. What emerged was a form of distributed command, less visible than generals on a battlefield, but just as decisive. Success depended not on brilliance, but on alignment. And alignment, under wartime pressure, became possible in ways peacetime America had never experienced. Synthetic rubber did more than replace a material. It redefined sacrifice. Civilians accepted rationing not as inconvenience, but as contribution. Speed limits were obeyed not for safety, but for endurance. Tires were patched beyond reason. Driving became a calculated act. On the factory floor, workers understood that Every usable tire meant motion somewhere else. On a road in Texas, a runway in California, a supply line not yet named. The moral contract was quiet but firm. Accept less now, so the war can move forward. By late 1942, the pieces were finally aligning. Production stabilized. Compounds improved. Distribution found rhythm. The system no longer felt like emergency improvisation. It felt like momentum. And momentum, once achieved, carries its own force toward a decisive turning point where adaptation becomes transformation and survival gives way to dominance. That moment arrives when America proves it can not only replace rubber, but outproduce loss itself. By early 1943, the crisis reached its narrowest point. Stockpiles were low. Military demand was peaking. New theaters of war were opening faster than supply lines could stabilize. North Africa had consumed vehicles at a brutal rate. The Pacific demanded mobility across jungles, coral, and improvised airstrips. Europe loomed, vast and hungry. There was no margin left. Inside the synthetic rubber plants, output figures were watched like casualty reports. Every week mattered. Every incremental gain meant the difference between readiness and delay. Then, slowly, the numbers began to turn. Styrene butadiene rubber, once unreliable, once dismissed, started to behave. Not perfectly, but predictably, blended with carbon black, vulcanized under revised temperatures, molded into tires redesigned for the material rather than copied from natural rubber models. This shift was critical. Engineers stopped asking synthetic rubber to imitate nature. They allowed it to become something else. Tread patterns were altered to reduce heat buildup. Sidewalls were reinforced differently. Tires were rated honestly, not optimistically. Shorter lifespan was accepted in exchange for reliability under load. The first large-scale military trials followed. Convoys ran longer routes. Aircraft logged extended hours. Tanks maneuvered harder terrain. Failures still occurred, but no longer catastrophically and no longer unpredictably. Maintenance crews adapted. Replacement cycles stabilized. For the first time since December 1941, planners could calculate again. Behind the scenes, the machinery of production expanded at astonishing speed. Government-owned synthetic rubber plants came online one after another. Feedstock supply chains, oil, alcohol, styrene were synchronized. Bottlenecks were identified and crushed through sheer scale. By mid-1943, monthly synthetic rubber production exceeded 100,000 tons. The psychological impact was as important as the physical one. The fear of immobility faded. Not vanished, but controlled. The sense of emergency shifted into confidence. America no longer waited for rubber to arrive from overseas. It made its own. Yet one question remained unresolved. Could this new rubber endure the ultimate test, sustain combat under the most demanding conditions of the war? That answer would come not from factories or laboratories, but from the fields, roads, and runways where the war itself would decide the value of adaptation. The proving ground was the world itself. In the summer of 1943, synthetic rubber tires rolled into environments no laboratory could simulate. North African deserts shredded tread with heat and sand. Italian mountain roads punished sidewalls with stone and switchbacks. Pacific airfields, scraped from coral and jungle, tested landing gear with every touchdown. Reports came back not as headlines, but as data. Failure rates declined. Maintenance intervals normalized. Tires wore faster than their natural predecessors, but they wore evenly. Predictably, commanders learned to plan around them. By the time Allied forces prepared for the largest amphibious operation in history, the question of rubber was no longer a strategic uncertainty. It was an industrial fact. Landing craft, trucks, artillery tractors, and aircraft assembled for the invasion of Europe were equipped almost entirely with synthetic rubber components. Not because it was superior, but because it was available, reliable, and under American control. The shift was complete. In less than 2 years, the United States had built the largest synthetic rubber industry on Earth. From near-zero production in 1941 to more than 800,000 tons annually by 1944. A transformation driven not by market forces, but by existential necessity. The enemy had unintentionally forced innovation. Japan's seizure of Southeast Asian rubber plantations had aimed to weaken Allied mobility. Instead, it severed America from dependence itself. The strategic gamble backfired, not immediately, but decisively. By late 1944, natural rubber imports resumed in limited quantities. They were no longer critical. Synthetic rubber now dominated military use. Civilian tires followed. The crisis that once threatened paralysis had produced redundancy, resilience, and scale. What began as improvisation ended as mastery. And mastery reshaped more than the war. It reshaped the chemical industry, industrial policy, and the post-war economy in ways that would echo long after the last convoy rolled home. Those consequences, measured in factories, labor, and long-term power, define what came after victory in the rubber war. When the crisis passed, it did not do so with celebration. There was no ceremony marking the moment America stopped worrying about rubber. No declaration. Only the quiet disappearance of panic from memoranda and the steady normalization of logistics reports. By 1944, the numbers spoke for themselves. Synthetic rubber production in the United States exceeded all pre-war natural rubber imports combined. More than half of every tire produced for military use was fully synthetic. The remainder used blends designed to conserve natural latex wherever possible. Convoys moved without ration miles. Training schedules expanded. Aircraft readiness rates climbed. Mobility, once fragile, became assumed again. For civilians, restrictions eased slowly. Tire rationing remained in place until the war's end, not because rubber was scarce, but because planners remembered how quickly abundance could vanish. Driving habits had changed. Maintenance culture had hardened. Waste felt unpatriotic. Industrially, the shift was permanent. Factories built as emergency measures did not close. They evolved. Chemists who had been hired for wartime improvisation became architects of peacetime expansion. Polymers developed under pressure found new uses in consumer goods, infrastructure, medicine. Rubber was no longer just harvested. It was engineered. The military absorbed the lesson deeply. Supply chains were redesigned around redundancy. Single-source dependencies became unacceptable risks. Material science was elevated from support function to strategic priority. The war had proven that battles could be lost before they were fought if materials failed to arrive. Yet success carried its own cost. The synthetic rubber program had consumed enormous resources, billions of dollars, massive energy input, environmental impact largely unmeasured at the time. Efficiency had been sacrificed for speed, and some of that inefficiency would linger into the post-war years. Still, the outcome was undeniable. A vulnerability had been exposed and eliminated. As victory approached, attention turned to what this transformation meant beyond the immediate relief of solved shortages. How it reshaped labor, industry, and the American relationship with technology itself. Those deeper consequences unfold in the final stage of aftermath. The end of the war did not end the system that war had built. When peace arrived, the synthetic rubber plants did not shut down their reactors or drain their vats. They slowed, but they remained. The infrastructure was too valuable, the expertise too hard-won to dismantle. Natural rubber returned to global markets. Ships again crossed the Pacific carrying latex from Southeast Asia. Prices dropped. Plantations reopened. But the old dependency was gone. Industry had changed its calculus. Synthetic rubber was no longer a substitute of last resort. It was a parallel supply. Predictable, controllable, domestic. Blends became standard. Engineers selected compounds based on purpose rather than availability. Tires for heavy loads, extreme heat, or chemical exposure increasingly favored synthetic formulations. The chemical industry expanded outward from rubber into plastics, resins, and advanced polymers. Wartime collaboration normalized information sharing between government and private firms. Federal funding of industrial-scale research, once controversial, became accepted. Labor changed as well. Thousands of workers trained during the emergency carried their skills forward. Chemical technicians, process engineers, quality inspectors, roles that barely existed before the war, became permanent professions. Industrial America grew more technical, more specialized, and more dependent on scientific expertise. The strategic mindset shifted too. Military planners institutionalized what the rubber crisis had revealed. Wars were no longer decided solely by weapons or tactics, but by materials, by access to molecules, feedstocks, and industrial throughput. Future conflicts would be planned with that reality embedded from start. In hindsight, the rubber crisis appears brief, just a few years, but its effects stretched across decades. It altered how America thought about risk, about preparation, about the cost of convenience. The nation had learned, under pressure, that modern power is not only forged in steel or measured in firepower. It is compounded quietly in laboratories and factories long before the first shot is fired. That realization lingers, inviting a final reflection on what this episode truly meant, not just for victory, but for the shape of the modern world. When the crisis passed, it did not do so with celebration. There was no ceremony marking the moment America stopped worrying about rubber. No declaration, only the quiet disappearance of panic from memoranda and the steady normalization of logistics reports. By 1944, the numbers spoke for themselves. Synthetic rubber production in the United States exceeded all pre-war natural rubber imports combined. More than half of every tire produced for military use was fully synthetic. The remainder used blends designed to conserve natural latex wherever possible. Convoys moved without ration miles. Training schedules expanded. Aircraft readiness rates climbed. Mobility, once fragile, became assumed again. For civilians, restrictions eased slowly. Tire rationing remained in place until the war's end, not because rubber was scarce, but because planners remembered how quickly abundance could vanish. Driving habits had changed. Maintenance culture had hardened. Waste felt unpatriotic. Industrially, the shift was permanent. Factories built as emergency measures did not close. They evolved. Chemists who had been hired for wartime improvisation became architects of peacetime expansion. Polymers developed under pressure found new uses in consumer goods, infrastructure, medicine. Rubber was no longer just harvested. It was engineered. The military absorbed the lesson deeply. Supply chains were redesigned around redundancy. Single-source dependencies became unacceptable risks. Material science was elevated from support function to strategic priority. The war had proven that battles could be lost before they were fought, if materials failed to arrive. Yet success carried its own cost. The synthetic rubber program had consumed enormous resources, billions of dollars, massive energy input, environmental impact, largely unmeasured at the time. Efficiency had been sacrificed for speed, and some of that inefficiency would linger into the post-war years. Still, the outcome was undeniable. A vulnerability had been exposed and eliminated. As victory approached, attention turned to what this transformation meant beyond the immediate relief of solved shortages. How it reshaped labor, industry, and the American relationship with technology itself. Those deeper consequences unfold in the final stage of aftermath. The end of the war did not end the system that war had built. When peace arrived, the synthetic rubber plants did not shut down their reactors or drain their vats. They slowed, but they remained. The infrastructure was too valuable, the expertise too hard-won to dismantle. Natural rubber returned to global markets. Ships again crossed the Pacific carrying latex from Southeast Asia. Prices dropped. Plantations reopened. But the old dependency was gone. Industry had changed its calculus. Synthetic rubber was no longer a substitute of last resort. It was a parallel supply, predictable, controllable, domestic. Blends became standard. Engineers selected compounds based on purpose rather than availability. Tires for heavy loads, extreme heat, or chemical exposure increasingly favored synthetic formulations. The chemical industry expanded outward from rubber into plastics, resins, and advanced polymers. Wartime collaboration normalized information sharing between government and private firms. Federal funding of industrial-scale research, once controversial, became accepted. Labor changed as well. Thousands of workers trained during the emergency carried their skills forward. Chemical technicians, process engineers, quality inspectors, roles that barely existed before the war, became permanent professions. Industrial America grew more technical, more specialized, and more dependent on scientific expertise. The strategic mindset shifted too. Military planners institutionalized what the rubber crisis had revealed. Wars were no longer decided solely by weapons or tactics, but by materials, by access to molecules, feedstocks, and industrial throughput. Future conflicts would be planned with that reality embedded from the start. In hindsight, the rubber crisis appears brief, just a few years, but its effects stretched across decades. It altered how America thought about risk, about preparation, about the cost of convenience. The nation had learned, under pressure, that modern power is not only forged in steel or measured in firepower. It is compounded quietly in laboratories and factories long before the first shot is fired. That realization lingers, inviting a final reflection on what this episode truly meant, not just for victory, but for the shape of the modern world. The rubber crisis of 1941 did not begin with an explosion. It began with a realization. The modern nation, armed and mobilized, could still be immobilized by the loss of something ordinary, something overlooked, something grown far away and assumed permanent. America did not solve the problem with conquest or diplomacy. It solved it by changing how it understood technology. Synthetic rubber was not a miracle discovery waiting to be unlocked. It was an unfinished idea forced into maturity by necessity. In laboratories and factories, failure became instruction. Chemists learned that materials do not need to be perfect, only reliable. Leaders learned that speed sometimes matters more than efficiency. And a nation learned that dependence, even when cheap and convenient, carries hidden risk. The tires that rolled across Europe and the Pacific were not symbols of innovation. They were symbols of adaptation, proof that industrial power could bend under pressure without breaking. After the war, natural rubber returned. The crisis faded from memory, but the lesson endured. Modern warfare and modern life rests on supply chains as fragile as they are vast, on materials whose absence can halt motion, silence engines, and ground ambition. Preparedness is not only about weapons and storage, but about knowledge in reserve. In 1941, America discovered that the smallest components can carry the heaviest weight. And in answering that challenge, it reshaped its industry, its science, and its understanding of what it means to move forward when standing still is not an option.